Go.
Hi, I'm Karthik and we'll try and study a few tricky concepts of Java. Okay, so topic for today that I've chosen to talk about is, as you can see, dynamic method dispatch. Now before we do this topic, I'll expect a few basic concepts of Java already in place. Like for example, if I use something like dog d equals to new dog, what does this mean inside the memory is what is very important for us to understand before we even go to that topic. If I have to do this in terms of what happens inside memory, you will understand this in 4 steps. Whenever you write this statement, the first thing that happens is this, new dog. New dog means there is a memory allocated on something known as a heap that Java uses for its memory allocation. Okay? So there is something known as a dog object which is created inside the memory, which is the first thing that happens. Second thing is dog d. Now this is something which happens outside the memory, which is a normal variable with the name d. Okay, that's the second operation. Third operation is the equal to, or what we call it as assignment in programming languages. So what happens is this thing, the address of this is assigned to d, which means address of this object assigned to here effectively means this guy starts pointing to this particular object, which means this is the guy who has the reference or the address of the object of, and this is the actual object. So this takes us to 3 important functions. The 4th important function that I'm presuming you know are the constructors that are being called. Okay, so these are the 4 functions that happen. So the point is, whenever we create an object in Java, this is how it is created and this is what it means inside the memory. So whenever an object is created in Java, not only an object is created but also a reference variable outside the heap, okay, which is pointing to this. So just to make it easy and to make it more palatable for you, I will name this as a TV and this as a remote control, just because we control it from outside the heap. Okay? So this is our remote control, this is our TV. This is the guy through which we'll be controlling this particular object. So whatever methods, whatever variables we will need to call of dog will be done using d. So typically a call like d.bark, a d.eat or a d.sleep will be made, but it has to be using d. Clear? So yeah, so that's the basics of class and object that happens in Java. Now we need to come to our topic of dynamic method dispatch. I'll give you an example. If we look at a inheritance hierarchy, say this is class A with variables x and y, okay, and say a method show xy which displays the values of these 2 variables. Now there is a subclass of this class, say B, which has variables p and q and a method show pq, and there is another class C which has method say rs. Sorry, these are 2 variables rs and the method show rs. Now this is what it is. This is just a logical view of what the class will be. So these are our 3 classes, A, B and C. As you can clearly see, this is a subclass, this is the middle class and this is the derived class of all. Okay, has 2 variables x and y and a method show xy. 2 variables p and q and a method show pq, 2 variables r and s and a method show rs. Now how does this topic help us in a particular inheritance hierarchy? If I have to tell you properly, if you think, when I create an object of class A, for example in a statement like A equals to new A, if you can imagine properly, something like this happens in the memory. An object of A is created having space for 2 variables, so x and y. So a TV with say 2 rooms have been created and a reference variable outside which points to this particular object. Okay, this is what happens when we create for A. Very important is to understand what happens when we do for B. What happens with B is, if you write B equals to new B, what happens is very important. Now B has P and Q of its own. At the same time, B is also deriving from A. So B has 2 variables from A and 2 variables of its own. Not only the variables, B also derives the method show xy and show pq is its own. So when you create something for B, there will be a TV created with 4 rooms. Very important. X, Y, P and Q. So there is X, there is Y, there is P, there is Q, and there is B outside the heap pointing to the actual object. This is what happens when you create for B. I am assuming you will know what will happen when you do it for C. So when you do a C, C equals to new C. This is something what is going to be taking place inside the memory. 6 rooms, X, Y, P, Q and RS. Okay. So this is X, Y, P, Q, R and S. This is what the objects in the memory will look like because of the inheritance tree. Okay. Now, where does this topic come into the picture? Dynamic method dispatch effectively means something on the lines of a universal remote. I don't know if you've heard about it, but a universal remote control is a control which can be used to control different TVs. Okay? So what we are going to do is now develop a common remote control which can be used to access all the 3 TVs. What you have to agree with me here is this guy can not only work with X and Y but also call show XY. This guy can not only work with XY PQ but also call show XY and show PQ, and similarly therefore C will be able to call show XY, show PQ and show RS. As far as the names of the methods are different in every class, the issue does not rise. We cannot make a universal remote. For us to be able to do dynamically dispatch of methods, method overriding has to take place, which is very important. Now, method overriding means the methods with the same names are present in the class. So, effectively, this will be like a method show, which will obviously show X and Y, but I have named it as only show. This also I will name it only as show, and this also I will name it only as show. Now, whenever in the inheritance hierarchy the classes have the method with the same name, which means method overriding has taken place, dynamic method dispatch comes to our rescue of creating a universal remote with the help of one particular to control different TVs. Okay? Let us see how do we do that. So what you have to understand here is when you've created object of type A, okay, this is your object, this is your remote control. If you have to understand in terms of remote control, this guy has got 3 things within himself, X, Y and show, which means you can understand that this remote has 3 buttons on it. 1 button is for X, 1 button for Y and 1 button for show. Similarly, B, do you think will have how many buttons? Correct, it should have 5 buttons, X, Y, P, Q and show. So B will effectively have 1, 2, 3, 4 and 5 buttons. Why only 1 button for methods? Because the method name is same, the method is overridden. So there will not be 2 different buttons for show, there will be only 1 button for show. Okay? But P, Q, X, Y are different variables and therefore there will be separate buttons for it. Okay? And exactly on similar lines when you do it for C, it will be 1, 2, 3, 4, 5, 6 and 1, 7 buttons. So 1, 2, 3, 4, 5, 6 and 7 buttons for C. Okay? Important thing to be noted is every remote control has a button by the name of show. Every TV, if I may call it, every TV has a common channel by the name of show. But what is more important to understand is this TV's show method or show channel shows X and Y values. This TV's show channel shows only P and Q values, and this TV's show channel will show the values of R and S. So the name of the channel is also same, but what they will do, what they are doing, what they are showing is different, which means the work that they do is different. Okay, so let us see how do we do it now. You can see there A equals to new A, which means there is a remote created and then there is a TV created. Okay, in Java you can obviously point a superclass reference to a subclass object. A superclass reference to a subclass object, which means a statement like this, A is equal to B, with reference to this A and this B is absolutely valid. What is here is very important. What is inside B? Ultimately B is a reference variable, which means B has address of this object and that address is passed on to A. when that address is passed on to A stops pointing to this TV and starts pointing to this TV. Okay, so as soon as you write this statement, A starts pointing to this particular TV. Now, after this, if you do an A dot show, do you agree that A has a channel or A has a button, remote control A has a button by the name of show? Yes, because there is show. And B as a TV also has a channel by the name of show. So because you can do it A dot show, what will happen is, using remote of the TV of type A, you are still controlling TV of type B, able to show the channel show. Clear? So when this happens, A dot show, class B's show will be called, which is very important. Before this statement, if you would have written A dot show, which means after these three, if you would have written A dot show, your class A's show would have been called. Your class B's show will be called. As soon as you write a statement like this, A is equal to C, A is equal to C, what happens is, whatever C has gets into A, normal assignment operation, whatever C has gets into A. So C has the address of this, gets into A, which means A now stops pointing to this guy and starts pointing to this guy. We again know that A also has a button by the name of show, this guy also has a channel by the name of show, which means when we do this A dot show, now what do you think will be called? Yes, of course, C's show is called. Clear? So what you have to understand here, and what we've done is a very, very important fundamental, that only by creating one reference of the supermost class, creating one reference of the supermost class, using that reference, you are able to access show of all the subclasses in that inheritance tree. And this is exactly what is called as dynamic method dispatch. Now, why dynamic? What is dispatch here? Dynamic because you don't know who A will be pointing to until and unless the runtime, until unless these things are executed, and therefore the word dynamic. Okay, so dynamically it is decided that this reference variable A will be calling show of which class. So that is how methods are dispatched. So this decision of A will call whose show is deferred or taken only at the runtime, cannot be taken at compile time, and this is what makes the entire feature dynamic. Okay? So this is the concept of dynamic method dispatch. Thanks.